The overarching theme of what I'd like to talk about is software development using GitHub Codespaces. Now, in order to use GitHub Codespaces, the first thing you need to do is have a GitHub account. So what I've done is I've brought you up to the GitHub login page. So if you just go to github.com, if you have a GitHub account, you can go ahead and sign in. If you don't have a GitHub account, you can go ahead and sign up. So the first thing you want to do, if you don't, is go ahead and sign up, and then we're all on the same page. So what I'm going to do now is assume that we all have GitHub accounts, and I'm going to go ahead and sign in to my GitHub account. So when you sign into your GitHub account, you'll have something that looks along these lines. And if you haven't used GitHub before, this might just be a whole lot of busy inundating you with all kinds of what's going on here. But let's just go to something that ultimately what I want to do is I want to create a new repository. Now we can either do that from here, or if you are a GitHub user, then you may or may not have existing repositories. So if you click over here, you can see that I'm signed in as Ryan2135, and I do have some existing repositories. So ultimately, when you start creating repositories, your situation when you log in is going to look something like this. Okay, so if you don't have any repositories, great. If you do, that's fine too. But what I want to do is I want to create a new repository. So I'm just going to go through creating a new repository and what this means. So the repository we're going to create is, we're going to call it Hello Codespaces, and it's going to be a public repository so the entire world can see our Hello Codespaces repository. And I am going to initialize this repository with a README. Typically, repositories are where we're going to store our code in the cloud. And typically, each repository has a README file, which the README file has specifics about what's important to know about your given repository. So that's it. Hello Codespaces. It's public. We're going to create a README, and we're going to create the repository. So this is actually going to create a repository in the cloud. Okay. So I want to show you what just happened, because for a lot of us, this is, if we don't understand the workflow, it's kind of hard to understand how to use this tool effectively. So I'm going to come over here and first of all, apologize for my artwork that I'm going to attempt to create. Okay, so I want to show you that what is existing in the cloud is going to be up here. And remember, software developing using GitHub Codespaces. So that's this is, you know, where I'm headed right now. So in order to get this far, we've got your computer. And on your computer, you are currently using a browser. And when we created Hello Codespaces, what happened was, in the cloud, we've got GitHub repositories, someplace up in the cloud on the internet. I mean, I'm sure you've all heard the term the cloud. And so we've got GitHub repositories. Now, if you're new to this, then right now you have one repository. So your repository is called Hello Codespaces. And in that repository, you can see over here, one file called readme.md. So this single file, and don't worry about the readme.md, it's just a special markdown file that's used to display text, and it has some special formatting codes inside of it that allow us to do some really nice things like bold and bullet lists and whatnot. And I'll talk about that at some other point in time. But right now, your browser then has access to this GitHub repository called Hello Codespaces. So you're on your computer, you're in a browser. Now, your computer could be a Mac, could be a Windows machine, could be a Chromebook, could be an iPad, could be a Surface, could be your phone, whatever. As long as you've got a browser, you've got access to this Hello Codespaces. And your computer, so again, the beautiful thing about this is that, you know, your computer can be anything. So the browser, again, Firefox, Chrome, Safari, whatever, and your computer, and you are now accessing some repository, Hello Codespaces, out in the cloud. Okay, so right now, that's the first picture that I want you to get in your head. Right now, we have created a single repository. It has a single file, and we have access to that repository via the browser. Next, what I want to do is I want to show you how to create a code space and what that actually means. In the last video, we talked about creating a GitHub account, and we created a GitHub repository. The GitHub repository we created is a repository called Hello Codespaces. We have a picture on the right that shows your computer and browser having access to this repository, Hello Codespaces. And now what I want to talk about is the creation of an actual code space. So right now, if you go to your Hello Codespaces repository, and again, you could, depending on where you are, you can see who I'm signed in as, and you can get to your repositories this way, and you should be able to see your different repositories. And if you click on the Hello Codespaces repository that we created last time, you have something that looks like this with a single README file, this markdown file. So how do we create a code space, and what is a code space? So you see this green button over here. If you just click on this green button, you'll see local and you'll see code spaces. Now, if you're familiar with GitHub, this local section here makes sense to you. If you're not familiar with GitHub, that's okay. Right now, I want to talk about code spaces. So if you click on code spaces, you can see that right now, your workspace is in the cloud. You know, I have no code spaces. So we are going to create a code space on main, and don't worry about what on main means. Essentially, we're going to spin up a code space, which is a virtual machine that is going to contain our execution environment. So this thing is spinning up right now. And while this is spinning up, I'm going to go ahead and shrink this down and show you a little bit more about what's actually going on. So what's happening right now is that there is a Hello Codespace Hello Codespaces VM So VM stands for virtual machine. And that virtual machine is going to have a hello codespaces repository. Now, this repository with this virtual machine is actually considered a local repository, where this codespaces repository on GitHub is called remote. Now, this might be a little confusing in the sense that both of these entities, this GitHub repositories is in the cloud, and this hello codespaces VM, this virtual machine is in the cloud also. And so what we just did is we created the virtual machine by clicking code and then creation of codespace on master. Now, another super cool feature is that, remember, we are doing all of this from our browser. So now we have a browser that has access to our GitHub repository over here, and also has access to our virtual machine, hello codespaces, over there on the right. And if we examine this environment over here, this is now our codespace. And this is a working environment that is going to allow us to be able to write code. And remember that the browser can be on a Windows machine, it can be on a Mac, Chrome, whatever. Your environment and your look and feel is going to be exactly the same as what it looks like over here. And what's being displayed right now is the README file, which is in preview mode. And I'll come back and talk a little bit about how we can actually modify this textually and then get a little different preview of our README file. So I hope this picture makes complete sense to you, because you've got to understand the difference between the GitHub repository that is a remote repository that exists on GitHub versus the hello codespaces virtual machine, which contains a copy of this remote repository. And I need to show you that this local repository is an exact copy right now of the remote repository. In this local repository is the file readme.md. So you can see when we created this virtual machine, the local hello codespaces repository is an exact copy of the hello codespaces remote repository. Now, typically what you'll do, or what we'll do, is we'll do our work on the local repository, and then occasionally, or more than occasionally, we will push our changes to the remote repository. So typically we work locally, we do a certain amount of work, and then we push to the remote repository. And this will be our workflow going forward. Time to have a little fun. So we have our code space that's running on the left over here. And right now we have a preview of the README file. So when someone takes a look at our repository, the README will be displayed. So you can see that this is the preview of this markdown file. Now, what if we want to make a modification to that file? So we can go ahead and see, if we click on this, it says show source. So let's go ahead and click on that. And this is the actual source file that's being rendered in preview mode over here. What let's do, let's add, so what have we done thus far? First thing we did was we created a GitHub account. So if you didn't have one, you created one. Second thing we did then is we logged in and we created a repository. And then the third thing we did was we create a Codespace VM. So those are the things that we've done to this point in time. And now the fourth thing is modified the README file. So we are currently modifying the README file right now, and we could preview what this looks like. If we come over here to preview, this is what it's going to look like. So you can see how this text over here, when we go into preview mode, gives us a real nice preview, and any browser that's going to display this readme.md, this is what it's going to display like. Now, what do we do with this modified README file? And where does this modified README file exist? So right now, we are in our Hello Codespaces VM, and this file exists as part of the VM. Okay, now we have not done anything as far as adding and committing this to our local repository. So there's a couple things. Well, there's one thing I want to show you first of all. If we come over here to this Codespaces and we refresh, you can see that this README file down here has not changed. All right. Now we're going to come back into this Codespaces, and you can see that this over here, we are in, we have the Explorer feature that we're presently in. We've got a search feature here, and this is a source control. And you can see that the source control has one pending change. Okay, so we have that readme.md file has been modified and it's been changed. So what are we going to do with that? So if you click on this, and I'll go ahead and expand a little bit. The first thing you want to do, so we need to commit this file, this modified readme.md, we need to commit that to our local repository. So right now, we're going to say added instructions. So this is what's going to show up in the repository for the changes that we just made, added instructions to README. And this blue says we have not committed yet. So let's go ahead and commit and see what happens. So if we click on this commit, it says there are no stage changes. So in GitHub land, we need to stage our changes and then commit them. So I'm always, every time I commit, I always want to stage them. I'm just going to say yes, because I'm always going to do this. I'll talk a little bit more about what this means a little bit later on. Now, here's what's important. What we just did was over here, you can see, I'm showing you in these dashed lines that the readme.md file in our local repository, we just committed the updated changes to that file. That exists. The readme.md is updated, but only locally. And again, I'm going to show you this if we come over here and we refresh again. Proof that our changes have not been pushed to this remote repository. Now, this asks, do you want to sync changes? And sync, it actually pulls down any changes from the remote repository to the local repository before pushing all of the changes back to the remote repository. And you might be asking why. And the bottom line is, typically GitHub is used a lot with teams. And so if you had someone on your team that had pushed to change to the remote repository before you incorporated those changes into your local repository, before pushing your changes back up remotely, that would be a problem. We are only starting to get the hang of this individually. So right now, syncing, pulling any changes, we haven't made any changes on the remote repository. So sure, go ahead and sync changes, pull them down. This action will do a pull and then push. Okay, so I'm just going to go ahead and say okay right now. Would you like code to periodically run git fetch? This would be more important if we were doing this in teams. I'm just going to say no right now. And you can see this is no longer dark blue. You can see also over here that there are no changes because we have pushed the changes to our remote repository. And here's the fun, super cool thing. Refresh. Now, when we pushed, those changes now exist in the remote repository. And so now both readme.mds in the remote repository and the local repository are reflecting the exact same thing. This is a process that you're going to want to do over and over and over. Hopefully, you're getting more comfortable with the concept of a code space and how GitHub works as far as we edit files locally, we push or we stage and commit changes to our local repository, and then we push to our remote repository. From time to time, we want to work in this terminal window down here. Many of us feel a little bit more comfortable in this environment. It's kind of more of an old school environment, and there are lots of commands that we can run in this terminal window down here. Prior to working in this terminal, everything that we've done has been using this Visual Studio Code GUI over here, and selecting the proper icon to take us to the Explorer, searching or source control. And when we committed, we typed our message into this text box up here and we hit the button. All of this work can be done from the command line in this terminal window. Command line and terminal, I'll use interchangeably. So let's go up here and edit this file. So I'm going to put work in terminal. So we just made a modification to this README. Now we are familiar over here with this source control. You'll notice that it says that there's one pending change, and that pending change is the modification of this README file. Okay. Now, also, if we come in preview, this preview is going to show our editing in this file. But I want to come down into this terminal window and show you also that we have a lot of power in this window down here. So the first thing that I want to show you is that this virtual machine over here, this Hello Codespaces virtual machine, is actually a Linux machine. It's a Linux virtual machine, and our local repository exists in that machine. And if you're familiar with Linux or any of the Linux commands, we can actually type those commands down in this window right here. For instance, we can do something like ls, which is going to list the contents of this directory. So right now we are in a directory, workspaces, and inside of that directory, Hello Codespaces. It's just like folders. So for those of you that have just done GUI work, we're basically working in folders. So an ls shows us the contents of this directory. And right now you can see that there's one thing in this directory or this folder called readme.md. Same thing if we go over here into Explorer. You know, we see that we are in this directory Hello Codespaces up here, and in that directory there is a readme.md. So that's one thing. Now, so we can also do an ls space -al, and this gives us more information about this directory. Specifically, it gives us a longer list of what's in the directory, and also shows us special files and directories that begin with a dot. Now, in the Linux world, dot is your current working directory. ... is the parent directory, so that's one level up. .get is a directory or a folder that has information about the current GitHub, the Git repository, this Hello Codespaces, and then readme.md is a file. So if we come over here, you see that this D, and this D all specify directories. Again, dot the current directory, dot the parent directory, and .get is a directory for our repository. And then notice that there is no D here because this readme.md is just basically it's just a text file. Okay, we can do something like more readme.md, and what that will do is that will print out in this terminal the contents of this file. Okay, well, we already know what the contents is up here. That's fine. But ultimately, we're going to get into programming, and when we do that, being able to you know, do certain things from the command line is going to be very beneficial. Now, one of the reasons that I wanted to go into this terminal is that I also want to show you some super cool stuff and make sure that we understand a little bit better about what we just did in previous videos. So we have git commands, so we can do something like this. We can type git status, and git status tells us more than we want to know right now. But what I really want to show you down here is this in red. Okay, this in red shows us that readme.md is a modified file. Okay, and This also shows us that changes to this file have not been staged for commit. And remember, we have to stage the file and then commit to our local repository before pushing up. Well, we got all of that information over here, and that's a true statement. So why are you showing me this at the terminal? Well, I'm just showing you another, for those of us that like to work in the terminal, we can get, some more refined information down here if we actually want to. I mean, for me personally, I do a lot of work down in the terminal. I just feel more comfortable that way, and I like it, and I'm used to it. The other thing is that if we ever, at some point, I'll show you how to, you know, run your programs and do program development outside of Codespaces. And if you do things outside of Codespaces, then this is will also, potentially be beneficial for you. In any case, git status, okay, shows us that we have a modified README file. Now this use git add file to basically stage this readme.md is what we want to do if we actually want to commit to our local repository. So we can do something like this. We could say git add, and I'm going to do capital R, and I'm going to hit the tab. And I hit the tab, and that's going to auto-complete. If capital R, if there's only one file in there that starts with capital R, then the terminal knows that when I hit tab, that's the file that I'm looking for, and autocomplete. So I don't have to write the rest of that file. Now, when we do a git add readme.md, this actually stages the file. So I'm going to go ahead and hit return, and that file has been staged. So if we do a git status, you can see that we've gone from red, which is not staged, to green, which this is staged. And if we want to, we can unstage. So a lot of times we might be doing some work. We want to stage a file. We'll go do some other work. And then it's like, I'm not ready to commit that. So you can unstage that file, do some more work, and then stage and commit a particular file. So for now, I just want to show you how to finish this off. So this thing is staged. Now you can do git commit -m. So the -m is going to be, this is the message that we would normally put, if we go to source up here, when we type in a message up here, this -m, this is the message. And we're actually just going to, instead of typing it in the window and hit commit up here, we're just going to type it into the terminal down here, this command that we're presently, the command that I'm presently working on, this git commit command. So the message is just going to be worked in terminal. So this will commit whatever has been staged. There could be one file staged, or there could be multiple files staged. However many files are staged, this is going to commit those staged files into, now look at the picture. The picture on the right is the local repository. So I'm going to go ahead and hit return. So now that has been committed. And so now if we do a git status, there is nothing to commit. Okay. Everything that has been changed has been committed. Now, it's only been committed locally. This is not committed to our remote repository. Now, also look up here how Studio Code has, now it's like, do you want to sync these changes? Well, sync the changes, again, remember that's pull down and then push. And I don't always, again, right now, I know I haven't made any changes to the remote repository, so there's no need for me to pull and then do a push. So all I have to do now, well, I guess one last thing, I'll come over here and show you. Again, I refresh, and you'll see that this is our remote repository, and the changes have not been made to the remote repository. So I'll come over here and I'll go back into the terminal window and I'll do a git push. And if we do a push, this is going to push from our local repository. So again, the picture on the right, pushing from the local repository to the remote repository. And to just show that it's been done, well, we can look at two things. One, this is no longer bold. And the second thing is we can come over here and we can refresh, and you can see that our changes have been made. Okay, so from time to time, we're going to be working in the terminal down here, especially when we get into coding. And another thing, if we do an ls space -al, again, we could take a look at this, file, this readme.md down here. And again, if I just do r tab more, this just shows us the contents of that file. For many of us, this is exciting. And if you do any kind of development, you're going to end up in this terminal world from what's called the command line, typing in these Linux commands. You're going to get comfortable with that. And I promise you, you're going to enjoy it and it's going to be meaningful. But you've got a couple ways now to go ahead and edit your programs. And then if you want to use the GUI over here to do all of your commits and pushes, you can do that. If you want to come down to the command line, you can do that. The cool thing about programming and development and whatnot, there's most of the time there are many ways to accomplish a particular task. The last thing I want to show you before we actually start developing in Codespaces is the fact that right now we are running a Codespace and we have minutes that are being logged. And if, for instance, right now you want to take a break and go grab lunch or something like that, you don't want to just leave this Codespace running. Okay, so if we go to github.com/codespaces, this will show, remember right now I'm Ryan2135, this will show the Codespaces that I currently have. And you'll notice that there is this one right now that is active. So this Codespace right here has, and if I hover over this, it's using 2 cores. So if you're familiar, with cores hardware-wise, processors now have cores. So this is a virtual machine that has basically 2 cores, 4 gigabytes of main memory, and 32 gigabytes of hard drive memory. Okay, that's kind of what this means. All right, and that this is active. So if we come over here, this Codespace is the active Codespace, and it's running. And minutes are being logged. Now, there are, in a given month, 180, at the time of this recording, 180 hours per month of Codespace usage, or usage for this virtual machine that you can have. Now, that's 180 hours per core. These are 2 core virtual machines right now that I have created. And so that takes 180 down to 90 hours of 2 core machines. You have the ability, if you want more powerful machines, to go from more powerful virtual machines, to go from 2 core, 4 core, and so on. Just know that it's 180 divided by 2 or 180 divided by 4 or 180 divided by however many cores you want to create. For everything that I'm going to be doing or showing you, 2 cores, the default 2-core setup for this is just fine. In the time that I've been talking to you, minutes have been logged, and I haven't done anything over here. And that's fine. I mean, a couple minutes here or there, it's not a big deal. But like I say, if you have to go run errands or do lunch or whatever, and you're going to be gone for an extended period of time, shut the code space down. Now, there is a default time that if this code space is idle, will automatically be shut down. And don't quote me on this, but when I looked it up, I thought it was somewhere around 30 minutes, but don't quote me on that. And that could potentially change, from time to time, also. So right now, I'm going to take a little bit of a break. So if I'm going to take a little bit of a break, I want to shut this code space down. And the easiest thing to do right now is just to come over here, and I could just go ahead and stop this code space. And once I stop this code space, if we come over here, you'll notice that in our code space that we were using, you can see that it's being shut down. So the thing isn't quite shut down yet. The code space is being stopped. While this code space is being stopped, another thing that I want to show you, if we come back over, now this is our repository. This is the main GitHub repository. If I'm going to go ahead and extend this out right now, and I'm going to come up here and I'm going to show you one last thing. If we go down to settings and you go to billing and plans, right now, I mean, I haven't supplied, well, so right now my personal billing, I have $0. And you can see that there are various plans. Like I say, for most of you, 90 hours, if we're doing something educationally, 90 hours a month is probably going to be just fine. But you can see that in terms of code spaces, I'm coming down to code spaces, and you can see right now that this code space quota resets in 20 days. So remember, we have 180 hours per month. And so I'm basically 10 days into 10 days into when I started. My usage is 6.7 of 6.75 of 180. And you'll notice that it also says core hours used. Okay. So this, I've been doing a fair amount of work. I mean, not a ton, but I've still got a lot of time left. And, storage, not anything significant. So if from time to time you want to check, where you are, this is a good place to do that. So again, I mean, the purpose of this short video was just kind of to show you where your code spaces are, how to shut them down. And you can see that, I've got these 2 code spaces going now, that neither one, I'm sorry, I've created these 2 code spaces, and right now neither one is active. And if I come over here, that this code space is stopped, which is great. And so at this point, it's like, okay, I can go out and do whatever I want to do. And then when I want to, start cranking code again, I can come back and I can just hit this, restart this code space. Or if this window no longer exists, I can just come over here and I can just click on whichever code space I want to go ahead and start. It's time to put all the pieces together and create a Java code space and write a Java program, and let's see how the whole development process goes. You can see that I'm in my repository section on GitHub, and I'm going to create a new repository. So I'm just going to go ahead and hit new. Repository name is going to be Java Codespace. Right now, this is going to be public. I'm going to go ahead and add a README, and I'm going to create a repository. So we're really going through what we've done. This is just hopefully a nice review. We're going to create a code space on main, and we'll see how long it takes to spin this code space up. Remember, what's happening now is that a code space from our repository is being created. So a virtual machine is being created, and this code space over here is our remote repository, and this virtual machine has a copy of the repository, and we're calling this our local repository. Now you can see that code space spun up very quickly. We are now in our virtual machine, ready to basically write our code. Now there are some other things that we can do. We can come down here, and if we hit manage and we go to settings, there are, if you're not familiar with Visual Studio Code, then this is a way to begin to customize your environment. So one of the first things I like to do is I'm just going to go ahead and search for tab, and you can see that the tab size, when I'm writing Java programs, I like the tab size to be 2. If I'm doing Python, then 4 is okay. Languages that have braces, it's just my preference to go ahead and do 2. Another thing is that if we put in font, we can actually control our font size. So when I'm doing some recording right now, for you, it might be advantageous to go ahead and set this font size to a little bit bigger font size. Also, I'm refusing to get glasses, and so this is one way that I can continue to refuse to get glasses. Sorry about that. You can also change, whether you want light. Right now for recording, I find that white is actually best. But if you want to go ahead and pick a dark theme, you can go ahead and change your theme. There are many other ways that you can go ahead and change the settings. So I went ahead and changed that. Now we're going to go to the code space, and I'm going to create a new file. And the new file we'll just call hello codespace.java, and I'll go ahead and hit return. And now this is the beauty. Do you want to install recommended extensions for Java? Absolutely. Visual Studio Code in this environment will walk you through a lot of the extensions that you're going to need or want to write simple Java programs. So this is very nice feature because installing software and getting everything ready to roll, kind of a pain, but not in this universe. Now we can go ahead and run our program, or write our program. Now, public class, if you haven't done any Java development, the name of the class has to be the same name as the file name up here, hello codespace. So public class hello codespace. And then we're just going to do a simple let's just do a simple hello Java Codespace. That's it. Now, we can come over here, and if we click on this, we can go ahead and run or debug Java. I will show you both. Right now, we'll just start with run Java. So let me just go ahead and hit run Java. And this run debug features requires Java language, and we'll go ahead and say yes. Remember, this is a beautiful thing. We're on a browser. Anywhere we have a browser, we can open up a code space. This is going to be set. Now, I'm not going to go through all of the commands that were happening here. Basically, what I want to say is that the program needed to be compiled and executed. And once this program is compiled and executed, then the execution, you can see the result of the execution, which is hello Java codespace down here. A hello codespace.java file exists. A hello codespace.class file was created by the system automatically, and that this is the location of where that file actually exists, and that file is run on the Java virtual machine, and therefore we get our hello Java codespace output. This then is the entire process for setting up and developing a simple Java program. I'm going to save this off, going to come back and talk some more, but I hope you're as excited about this development environment as I am. And I hopefully this all makes sense, and you're having some fun. As I told you before, I tend to like to work in the terminal. And now that we have our program, our hello Java codespace program working, remember, this is our remote repository. And if we refresh this remote repository, this program over here has not been saved. We have multiple ways to do that. You can see over here that our source control shows us that there's one pending change. If we come up to the Explorer, then you can see we're back to where we have our Java program and we have our README file. If I'm down here, in previous videos, I showed you some Linux commands, and we did the git commands as far as how to stage, how to commit, and how to push. If I was going to work down here, then I could do, remember, something like git add. Now remember, this is going to add, well, let's go back just to refresh. Git status, this shows us that we have one untracked file. Hello codespace.java is an untracked file. So if we do git add, now I could do a git add hello codespace.java, or I could just do a git add dot, which says everything in the current working directory, stage those files. So if we do a git add dot and then do a git status, then you can see changes to be committed. This is the file that we can commit. So then we're finally commit and initial code commit. Not a great message. That's okay. If I commit that, then, and we do a git status, then you can see there's nothing to commit, and you can see that the message also went away over here. And now, as I've shown you before, this file still doesn't exist over here, but when we come down here and do a git push, then this will push from our local repository to our remote repository. And if I refresh over here, you can see that this file exists. And if I click on that, you can see that the file exists in our remote repository. And now our remote repository is all up to date and matches our local repository. couple of other things I want to show you, so from the command line, if you want to clear, you can go ahead and clear out the terminal, and that gives you a nice clean terminal. There's also we can do a Java -- version, and this shows us when when Java is executed, a Java virtual machine or JVM is created and our program is executed. That's what happened when we actually came up here and said run Java. Then this Java command is executed with our file, and a Java virtual machine is created and our program is run. Now, before our program can run, it has to be compiled. So there also has to be a Java compiler, and you can see that the Java compiler exists 17.0.5. All of this development, all of these tools, this JDK was installed when we created the code space. This work is done for us. I could, if I wanted to, I have set up on my Mac. So here's my Mac right here. I can do Java version, and I can do Java C version in a terminal window. And you can see that the compiler for this Mac is 16.01, and the one for this code space is 17.05. If you want to work on your Mac locally without the internet, you would have to set up a JDK and use Visual Studio Code, and that is all doable for you. My point is, right now, when you create a code space, all of that work is done. And that's just a really cool thing. So I will save this off and come back and give you a few more goodies as we move along into the Java development environment, writing Java programs with GitHub Codespace. I want to show you when we come up here and we say run Java. I want to show you what actually happens to make sure that you're good with what's going on there. And I want to show you from the terminal. So the first thing when we do run Java, remember, is that this hello codespace.java program has to be compiled. We can do that from the terminal. If I say something like Java, well, let me come back here. First of all, I'll show you. If I do an ls, you can see that the two files that exist in this directory, this Java codespace directory, are hello codespace.java and readme.md. That's the two files that show up here. If I want to compile hello codespace.java, and that's all I want to do is compile the program, I don't want to run it, I can just say Java C, and I'm going to do capital H, and there's no other file that starts with capital H, so I'll go ahead and hit a tab, which is going to auto-complete, and I'm going to hit return. And if I hit return, you will notice that now, because I'm doing this from the terminal in this directory, so this is working a little bit differently than when we hit run Java over here. When we hit run Java, the hello codespace class is saved elsewhere. Because we're doing this from the command line and doing just the compile, this hello codespace.class is saved in this directory. And if we do an ls, then right now, you can see that this class exists. Now, what is this class? This is hello codespace.class is compiled hello codespace.java. And this is what's called bytecode. And if you're familiar with Java, then that makes sense. And if you're just getting started with Java and you're getting development up and running, then that's new. Now, how do we execute that hello codespace? Remember, the compile and execution are both done when we hit run Java up here. We can say Java hello codespace, and we don't say hello codespace.class. We just say Java hello codespace, and what that will do is create a Java virtual machine JVM, it will load in this bytecode, hello codespace.class, and execute that program. And so if I hit return, you'll see that we get hello Java codespace. That is all happening automatically when we just say run Java. When we say run Java, the program is compiled and then executed, and we get our result. I could still come up here if we wanted to. We could say run Java, and this is going to be all of the magic that's set up for us using a code space, and the hello code space class that is the result of compiling the hello codespace.java, that is saved elsewhere. Now, one last thing. Right now, if we do a get status, we do not ever want these .class files to be saved to the remote repository or our local repository, because it's meaningless to save this bytecode, because if our program ever changes up here, this class file is actually meaningless. So we either want to delete this file, or in a lot of cases, what we will do is we will add a file called .getignore, and that .getignore says, what do you not want to be committed to your local repository? And so the pound sign is going to mean a comment. We don't want any compiled class files to be saved. And so now if we say star.class, it turns out that star matches any text to the left of this decimal point, or to the left of this period. So this basically just says anything that ends with a .class, you're going to ignore. Very important. All right. Now, if we come down here then and say get status, you will notice that the only thing that we need to add is this .getignore. And it turns out we do want the .getignore added to our local repository and then pushed later on down the line. But you will notice now that this hello codespace.class is no longer part of, I mean, basically Git is just completely ignoring that file. So the last thing that we want to do then is we want to add that file, and we want to commit added .getignore, and then we want to commit. Well, so once again, get status, and then I added the .getignore, and so finally then we're going to push our changes. And what we want to see over here is we want to see our .getignore, but we don't want to see hello codespace.class, and that's exactly what we've seen. Now, I know this is a little crazy, but I want you to really understand what Codespaces is doing when we actually run our Java program. I showed you from the command line down here. If you don't want to use the command line at all, that's great. All right, I'll just clear it. We can pretend it doesn't exist at all. Actually, one last thing, sorry. Let's go ahead and remove that hello codespace.class. So we can say remove hello codespace and I just use the tab there, and I'll go ahead and remove that. So that's another command that you can be familiar with if you want to use the terminal. You will, as you get into development, want to use the terminal. Well, we can go ahead and clear that out now. You can pretend that doesn't even exist. You can pretend I never even talked about this, and you can just go back and you can just do your run Java, and you can use these features over here, as far as your source control and explorer and searching and extensions. But I promise you that you will be using this terminal as you advance if you're just a beginner as far as Java goes. If you were just interested in Codespaces, which is what I really am trying to teach you right now, then just keep working with it. I want to spend a little bit of time talking about the debugger in a Codespace. Now, in the README file of the Java Codespace that we've been looking at, I actually modified the README to give a problem that I want to see if this solution to the problem is correct or not. And I want to use a debugger. It's kind of a contrived example to show you how to use a debugger, but the debugger is essential to any software engineer. And the nice thing about using the debugger in a Codespace is that the debugging is going to be the same look and feel no matter what computer you're working on. A lot of people look at the debugger as a very complicated piece of software and just don't use it because it just seems like too much trouble to get up and running. But I promise you that the sooner you start using the debugger, the better your life's going to be. Here's the problem. Write a Java program, ask the user to enter a numerator and a denominator of a fraction from the keyboard, output the fraction and the resulting fraction as a decimal to the keyboard. So here's the problem. Enter numerator, the user inputs 4, enter denominator, user inputs 2, and this is the output. Now, in beginning Java classes that I teach, a lot of times I'll get a solution that looks like this. So the question is twofold. One, is this problem, is there ambiguity in this problem? If not, is this solution correct? Now, if you haven't seen Java, this is going to look a little confusing, but don't get too, it's not that bad. We are going to input information from the keyboard or the terminal. As such, we're going to create a new scanner object, and this system in basically just says from the terminal. So the information that we're going to get is from the terminal, and we need to import the scanner from this Java util library. So we're going to have access to a scanner. Then we're just going to have 3 variables: numerator, denominator, and result. We're going to output enter numerator. The user then will input the numerator value. So this enter numerator is done with this statement right here. Then the user puts in 4, hits return. This statement processes that, places 4 into numerator, and then enter denominator. User inputs 2, and we grab that. The computer grabs that, puts that value in denominator, print out a blank line, and then we compute numerator divided by denominator and print out the result in a string, substituting in the values of numerator, denominator, and result. All right, so we're going to come over here. First thing we're going to do is we're going to create a new, because the class name is fraction, the file name has to be fraction.java. And we come up with this, and nicely, Visual Studio Code starts us off, and I can go ahead and hit tab. And if we were typing from the beginning, then we could go ahead and just type in our code. It turns out we have the code over here, so there's no point in you watching me type. I'm going to go ahead and select this, and then copy it, and then come over here and paste. And now we have our program inputted. From here, we know last time that one thing we could do is we could run this Java program. So we could go ahead and run. And our program's going to get compiled and it's going to get executed. And we see that this thing, the program asks enter the numerator. So we put in 4. Enter denominator, we put in 2. And 4 divided by 2 equals 2. Now, a lot of times, when people get some specification, which is what this is, people take a look at the specification, they get this right here, that's all the testing they do, and then they turn in their program. Now, whether you're in school or industry, internship, or whatever, there are testers, whether you're the tester or someone else is the tester, that run a bunch of test cases through the program to see whether the program works correctly or not. Just this one test is really not enough to say whether this program works or not. So let's go ahead and run another example. So if we run another example, we could say 10 and 5, and that looks like it works. Okay. Well, what about 5 and 10? 5 divided by 5 divided by 10 equals 0. How can 5 divided by 10 equals 0? If you don't know anything about Java or C or C++, then this might look like the computer made a mistake. I know when I first started, I was always hoping that the computer made some kind of mistake, but inevitably it was my mistake. That's the problem. Now, the best thing to do is, if this doesn't work, is that you can use the debugger and you can set a breakpoint and step through your program one statement at a time. So this, I clicked out here, and if this is dark red, we can go ahead then, and now instead of run Java, we're going to debug Java. And this is going to start the debugger. And now this is where a lot of people are like, oh, this is out of control. Okay. So there is a window over here, a variables window, and it shows your local variables. Now, don't worry about local right now. Basically, everything between this brace and this brace down here, you can think of as local. So there is a variable args. I'm not even going to get into what args is. Our scanner, remember, our scanner is just referencing this object that allows us to get input from the keyboard. And now this symbol right here shows us that this is the statement that we're on. Notice there is no output down here. So we want to hit this right here, which is step over. That's going to step over this line and go to the next line. So let's go ahead and hit it. Now notice that enter numerator is what was outputted. The next line that's going to be executed is this one right here. This line has not been executed. In order to execute it, we want to go ahead and step. Now, when we step, the computer now is going to be waiting for us to put a value in. So let's go ahead and put in 5 and then hit return. Now notice this statement was satisfied and the numerator over here is 5. So this isn't as complicated as it looks. Very useful, very beneficial. So far, this program is doing exactly what we thought it should do. So let's just go ahead and step over again and enter denominator and then step over. And now the computer is waiting for us to put in our next value. Let's go ahead and put in 10. Put in 10, and now you can see that the debugger is on this line. This line has not been executed so far, and our numerator is 5 and our denominator is 10. Everything looks great so far. So step, and that just, notice that moved us down. That just outputted a blank line here. Now, this line has not been executed yet. Notice you can hover over numerator and see that that's 5. You can hover over denominator, you can see that's 10. You can see that Visual Studio Code over here also shows us that numerator is 5 and denominator is 10. Or you can see in this window up here that numerator is 5, denominator is 10. So what happens? Now you'll see there's no result over here. There's not going to be a result until we step. So everything looks great so far. Let's go ahead and step. We step, and I said, because this is where result is equal to 0. So this shows us the statement that, is this giving us what we want? Now, I'm going to go back because there's no point right now. So result, you can see, is 0, numerator is 5, and denominator is 10. So if we go ahead and step and execute this, we see why we're getting 5 divided by 10 equals 0. So now we've identified a potential problem, which is right here. Okay. And so this one right here, this just says continue, so we can continue. And now our program is done. and we've isolated the problem. Now I'm going to go back and ask you, is this problem ambiguous or is this solution incorrect? And I would argue that this problem is ambiguous because what it seems to be showing us right now is that this is an integer, and these are all integers down here. So if you're not familiar with Java or C or C++, then you're kind of stuck. I mean, you could probably go out. I haven't even tried this. This is probably going to be a mistake, but y is 1 divided by 2, 0 in Java. Or y, so why does 1 divided by 2 equal Java? I'm not sure what this is going to show. So this right here says d equals 1 divided by 2, and when they output d, so then you'd come down here, and this says when you do 1 divided by 2, that is integer division because 2 operands are integer. That's integer 1 divided by 2. Hence, it resolves to 0 because it actually is an integer. This is 0.5, but 0.5 rounded down is 0. Now, that may or may not make sense to you. Again, you look at this, 1 and 2 are both integers. So 1 divided by 2 is equal to 0. So if you're new, that's kind of about the best you can do other than, try and ask some other questions. So right now, we know that an integer divided by an integer is an integer. So 5 divided by 10 is an integer. It's actually 0.5, but because it's an integer, 0.5 rounded down is 0. The answer, if you actually want 0.5, is to come up here and then change this to a double. And now, if we run this program and we put in 5 and we put in 10, we get 5.0 divided by 10.0 equals 0.5. Now, that doesn't look exactly like this. So I will leave you with, I hope that even though this was a contrived example, that you found the use of the debugger very useful. And the other thing is that if you're given a problem, whether it's an interview or whether it's something at school or whether it's something at work, it needs to be an unambiguous problem. So the question would be, if you got something like this, to whomever posed this problem, do you want these to be integers or do you want these to be doubles? Because you can't solve the problem if you don't know exactly what the problem is. I know this was a little long, but honestly, this is probably one of the most important videos that I can make for you. I cannot tell you how many people do not want to use the debugger, and I totally understand it. And when I first started out, I was exactly the same way. The debugger has probably saved months of agony for me. So I've gotten to use that time gardening or playing tennis or other things rather than trying to fix some kind of software without a debugger.